hit a baseball so hard that it will go in orbit around the Earth. Another question is, let's calculate that speed that we need to give to the baseball. So we know that the only force acting on the baseball is going to be the force of gravity, which has a magnitude of the mass of the baseball multiplied by the free fall acceleration, and is pointing towards the center of the Earth. Now, from Newton's second law, I know that the acceleration of the baseball is going to be equal to the net force on the ball divided by its mass. But because the only force that is acting is gravity, then I can say, well, this is just going to be Fg divided by the mass. And then when I substitute this mass times gravity, the mass here is going to cancel this other mass here. And I'm going to be left with free fall acceleration pointing towards the center of the Earth. From our knowledge of uniform circular motion, we know that the radial direction, which happens to be the one that goes towards the center of the circular path, is going to be the speed that I need to have in order to be in orbit squared divided by the radius of the path. But then from this other equation, I know that that acceleration is just free fall acceleration, g. So then I can very quickly solve for the speed to be in orbit as the square root of the radius of this orbit times free fall acceleration. Now, because I am near the surface of the Earth, we're going to make the approximation that the radius of that orbit is very similar to the radius of the Earth, right? That is because this distance is much smaller than the radius of the Earth. So then I can say that that is approximately 6.37 times 10 to the 6 meters. So let's plug in that number in here. So this is going to be approximately radius of the Earth times free fall acceleration, which then I'm going to have the square root of 6.37 times 10 to the 6 meters times 9.8 meters per second squared. Square root of all of that. Now, because I only want to get a rough estimate, let's say that I'm going to make some other approximations. I'm going to change this 6.37 10 to the 6. I'm going to change it to 64 10 to the 5. And this 9.8, I'm going to change it just to, say, 10. And then the units that I have is still going to be meters squared over second squared, but then I have a square root, so my units are meters per second, which matches what I was expecting because I want to get a speed. So now what I have is the square root of 64 times the square root of 10 to the 6. I have 10 to the 5 here, another 10, that's 10 to the 6 meters per second. Square root of 64 is 8. And then I have times 10 to the 3, which is the square root of this 10 to the 6 meters per second. So about 8 kilometers per second. Now, to put this in perspective, this is approximately 160,000 miles per hour. So we would need to go very, very fast in order for it to be in orbit. But yes, in principle, if we can give an object this speed near the surface of the Earth, then this object would be in orbit around the Earth. Now, the next question would be, how long would it take for this object to go around one circle? And that's what we're going to do in our next video.